Thank you so much, Thomas. And this entire collection continues to just absolutely astound me. Okay, Amber, so here it is. Can you walk us through the final image reveal?
Absolutely. Here we go.
The last image is, wow, look at that. So Amber, can you tell us a bit about what we're seeing here?
Of course. This stunning vista of the cosmic cliffs of the Carina Nebula reveals new details about this vast stellar nursery. Today, for the first time, we're seeing brand new stars that were previously completely hidden from our view.
There's something you want to point out here?
Absolutely. So honestly, it took me a while to even figure out what to call out in this image. There's just so much going on here. It's so beautiful. One thing that really stands out to me is you sort of get this sense of depth and texture from this new data. There's a lot going on. To call out a few specifics, first of all, in general, the Carina Nebula is a nearby star-forming region within our own Milky Way galaxy, about 7,600 light years away. And in this view, we see some great examples, first of all, of hundreds of new stars that we've never seen before. We see examples of bubbles and cavities and jets that are being blown out by these newborn stars. We even see some galaxies sort of lurking in the background up here. We see examples of structures that honestly we don't even know what they are. Like, what's going on here? The data is just so rich.
And there's something really special about the infrared. Infrared can actually see deeper into these star-forming regions.
Absolutely. That's one of the great things about infrared, is it really does reveal what's going on here in a really cosmic sense. And in general, what's happening in sort of this overall landscape is we have these gigantic, hot, young stars up here to the top of this rim, and the radiation and stellar winds from those stars is sort of pushing down and running into all of this. This is gas and dust, and of course we know that gas and dust is great raw material for newborn stars and baby planets. But there's a flip side to this story, and also a little bit of a mystery, because these same processes can serve to sort of erode away this material and stop star formation. So we have this sort of delicate balance going on of new stars being formed, but at the same time the star formation is being halted. And for me, when I see an image like this, I can't help but think about scale. You know, every dot of light we see here is an individual star, not unlike our sun, and many of these likely also have planets. And it just reminds me that, you know, our sun and our planets, and ultimately us, were formed out of the same kind of stuff that we see here. We humans really are connected to the universe. We're made of the same stuff in this beautiful landscape.
And actually, the Carina Nebula was one of my favorite images from Hubble. So Hubble looked at this as well, right?
Absolutely, yeah. The Hubble image of this is also spectacular. We saw it in a different kind of light when Hubble took an image of this particular nebula. And then you can see amazing things with Hubble, but when we zoom in to this new image, we're able to see so much more detail. And of course, all of us, you know, I grew up on Hubble, and all of us love Hubble. And I'm so excited to see what these two amazing observatories are able to do really in tandem with each other.
Thank you so much. And again, congratulations. It's been a pleasure to be working on this with you. I'm just amazed by what's been going on.
I am too. Thank you.
So as we're wrapping up, one of the things that I really have to say is the journey that we've been going on is so very dramatic for me. So we've gone all the way from the birth of stars, and we have all the way from the distant galaxies to the birth of stars. This is where we all began. This was the whole point of the James Webb Space Telescope, to figure out our origins from the very, very early days of the universe to star and planet formation very nearby.